ये प्रॉब्लम है. This problem is from H.C. Verma in Current in Conductors, chapter number 32 in the physics. And we need to find the current measured by this ammeter, this ammeter here, in the circuit shown in this figure. We have a 6-volt battery and it looks like the circuit is complicated. If you use the regular Kirchhoff law and all these things, you will need to have a loop here, one loop here, one loop here, one loop here, a lot of loops, and then the equation will become very complicated to solve, and the chances of error will increase. There is a trick in this circuit that you need to know, and that's what we will try to apply in this circuit. Let's say we mentally remove the resistor connected between A and B and C and D. There were two resistors here, something like 50 ohm over here, but for the moment just mentally remove them and let's see if we can add them back. Now look at the circuit, the 6-volt battery here. Current starts flowing from here, and from this point some of the current flows in this branch and the rest of the current flows in this branch. When the current flows in this branch, in the whole this branch, it returns, combines here and comes back here. The same way the current flows here through these 3 resistors and come back. What happens is, because of this flow of this current here, let us say this is 6 volt, this voltage here is 0 volt because this is 0 volt. There is a division of voltage between this point and this point, and there will be some voltage here and some voltage here. If we make this one 0, this will be, let's say, VD, this voltage you call VB. The voltages here will depend upon the relative values of these 3 resistors. In this case, all these 3 resistors are equal, so it's very easy to find. It's just 2 volt each. But the point that we are trying to do is, it's possible to find the voltages here. Now focus on the upper branch. In the same way, the voltages get divided in these 3 resistors, and that voltages here will depend upon the relative values of these 3 resistors. So here the problem is simple because this is 0 volt and all 3 are equal, so we know that this is 2 volt with respect to this point, and the drop across this is 2 volt, so the voltage here will be at this point will be 4 volt with respect to this volt. Why we are doing all this exercise? I want you to focus the voltage at C and voltage at D. In this moment, the voltage at D is same as the voltage at C because of the symmetrical structure of this resistors. These two are same, these resistors are same, so the voltage at C is the same as voltage at D. What does that mean? It means if we connect a resistor between point C and D, and if we try to measure the current flowing through this resistor, there will be no current whatsoever. In the same way, the voltage at A is equal to voltage at B, and therefore there is no current flowing in this resistor. And the condition would have been same instead of if we had like 10, 20, 10 ohm, 10, 20, 10 ohm. The condition would have been still be same. We could still apply the same thing. Or 20, 30, 40, 20, 30, 40. We could still have the same resistors here. It could still be the same if this is like 10, 10, 10 and this is like 20, 20, 20, 20, 20, 20. Because in that case also, because the ratios of the resistors are same, the amount of the voltage appearing on these voltages will be same as these voltages at B and C. So because there is no current flowing in this resistor, we can just remove them from this circuit, and then the problem becomes simple. So the problem that we had gets reduced to a simpler problem like this. The three resistors here are series resistors. They combine to have an equivalent resistance of 30 ohm, and these three resistors combine to become 30 ohm. And both of them are driven by the 6 volt, and this 30 ohm and 30 ohm are in parallel. So the effective resistance is R1 into R2 divided by R1 plus R2, 30 divided by 2, or 15 ohms. If there are two equal resistance in parallel, the effective resistance is half of this resistance. That is something you need to keep in mind for quick calculation. So the 6 volt battery is driving 15 ohm resistance. So the current in the circuit will be V divided by R, or 6 volt divided by 15 ohm. 3 into 2, 6. 3 into 5 is 15. So 2 by 5, or 0.4 ampere. This was the wrong calculation that I had done earlier. So make sure you pay attention to the details and don't get the wrong answer. That will reduce your marks that you get. So in problems like this, where we have resistors in between and the circuit is symmetrical, use this kind of apply this simple tricks to get rid of the resistors and calculate the effective current flowing in the circuit.